Okay, so today I want to present you some work that I've been doing. Some work I've been doing related to creating visualizations using linked data. So first, why do we want to do this? Because we have lots of data in the linked data cloud in different SPARQL endpoints, but it's really hard to make sense of that data given that they are usually multidimensional in terms of you have lots of predicates pointing to different other entities using multiple vocabularies. So sometimes it's hard to make sense of all of this, right? So one way to do this is to use graphical representation of the data, and each representation serves different purposes. So, for example, well, this I hope you can see this at the end of the room, but basically it's a table with different numbers. This is very useful to understand the exact value of certain measures, right? However, if we plot this into, say, a graph, you can see certain things that otherwise wouldn't be noticeable. So, for example, here you can see there are some trends, but in general, there is a larger trend of increasing values and smaller trends here of ups and downs. On the other hand, these other values are more or less constant. However, you can see that this is a distinctive value because it's lower than the majority. So as you can see, different graphical representations or visual representations can help you to get a different idea of what this data is composed and sometimes to get a bigger picture of it. So one problem now is that it's hard to create these visualizations. It's not an easy task. So to do that, I created Visualbox, which is we can say it's basically a special edition of Loudspeaker, a simplified special edition. And what it does is Loudspeaker plus a set of new and already existing visualization filters. I will show you later what is that. But basically, it allows you to create different types of visualizations using a GUI. And it's basically inspired by the idea that having good data makes your life easier to manage that data, right? And in fact, the problem here is how to obtain the data we want, and the rest should be a no-brainer. Should be you shouldn't struggle with the code. Unless it is really necessary. So here's the interface of Visualbox. Hope you can see you have a set of components. A component in Loudspeaker and Visualbox is a group of queries or models that are here, and one or more views or templates that are here, right? So in this case, this template, the code of the template is here, it's available here, and the code of the model, in this case it's a SPARQL query, it's available here, right? But by the way, I'm really interested in your feedback on this tool. So you can interrupt me anytime you want. You can ask questions. You can give me your comments.
So is that, just to go back there, so models.main is referring to this particular query?
Right. This is a query called main, and that will retrieve, it will be executed against a certain endpoint, right? So models, as I said, basically are select SPARQL queries, right? And conceptually, as you should know, a select SPARQL query returns a table in conceptual. So this shouldn't scare you, I hope. Basically, this is a table of persons that knows another person, right? And you obtain a set of a table with URIs. Okay, that's a model. It's just a SPARQL query. And on the other hand, you feed the results of that query into this template, right? Now, how do you do that? You use I use Hanga, which is a library similar to the Django templating system for those of you who know Python. And this is very. I try to make it as simple as possible. So you iterate over the results of this query, of this model, and you put you write down the variables and the value of the variables into the HTML. So the results of this iteration would be something like this. Okay. All this applies to Loudspeaker as well as Visualbox. Now, one interesting thing we can do also is to apply filters. Can you see the code at the end of the room? Okay. So basically, you take the value of the variable, you apply a bar and a specific filter that modifies the value and returns something different. So in this case, upper gives you the uppercase version of whatever is the value of the variable. But now we can explore that idea and create visualization filters. So we give the whole results from the query to a visualization filter that will generate the code to create a visualization. So this query basically what requests is all the countries that has Nobel Prize winners in physics and its name, right? So it looks complicated, but actually it's pretty simple. The result conceptually is a table, say country label and total, those are the variable names, and a list of values, right? So when we apply this filter, Google Vis pie chart, and colon, and we give, in this case, the variable names. Remember, the variable names here are country label and total. What it's generated internally is, in this case, it takes the Google Visualizations API and generates a pie chart, right? So now, I want to repeat this. The hard part is to retrieve what we want, but nothing else, right? The code here is just one line of code. The rest is just to be HTML compliant, right? And in general,
So I'm sorry to interrupt.
sure.
The Google Vis pie chart is a filter that you've defined somewhere. And you've defined it as one that accepts parameters. So it's going to pull out those two columns.
Right, so I record the first variable is the string name, and the second one will be the value, right?
Okay.
And Visualbox will generate all the code necessary to generate the visualization. Now, in general, with the tabular data, this is pretty straightforward. So we can see we change using the same query, just changing the name of the filter. We have a column chart, we can have a bar chart, we can have a line chart. It's not really meaningful line chart, but I just wanted to show you that it's possible. But now we can start doing some more complicated but interesting things. So for a start, we can also include maps, right? Right now, Visualbox only has Google Maps, but I was thinking of using Leaflet, for those of you who know it. In this case, I'm just asking the latitude and longitude of certain and the area of different cities, right? This is give me a city, the latitude and longitude, and the area, right? Of the largest cities in the U.S. I think. No, this is for in general. So the results here is again a table, right? With latitude, longitude, and area, and adding these variables here to the Google Maps filter will give me this map. As you can see, you can add more variables, and this is the part that for me gets confusing in terms of how usable is this and how comfortable would users would be with this kind of interface or notation. But in this case, you can see you can point to different cities that has different that were selected from the query. Now we can add more complex visualizations. In this case, I want the wheelbase, the car width and car length of all the Lamborghini cars available in Wikipedia. Okay. So again, the data obtained is the label and all that data, right? And now I add a new filter, which is to generate parallel coordinates. These parallel coordinates will give me a representation of different values, and when I hover over a line, the name appears in the interface, and all that. It's really useful to understand different trends or when you have an outlier in terms of multiple dimensional data, etc. Now things are getting more interesting when you try to use graphs as an input for the filters, right? In this case, again, the same query, and I just can use the force graph to create a D3 force graph that represents this graph. Now the point here, and this will be important in the next slide, is that the table, since we have to stick our data into a table because of the table nature of the select SPARQL, where this or I decided that the best representation possible of a graph in a table should be a child-parent two-column table, right? At least that should be the basic. Again, I'm really interested in your feedback about this, and if you say no, I think that's wrong, you should do something else to represent this, a graph in a table. I'm more than happy to hear about that.
Well, you would just create a different filter, right? I mean, this is how this particular filter D3 force graph is implemented, right? Mm-hmm. And you would just have a different one, force graph 2, if there was some different.
Yeah, no, but I mean, in general, the idea of representing a graph in a table. That's,
I see.
So, and I'm telling this just because what happens when you have a tree, you want to create a tree visualization, a tree-based visualization, right? Where the nature of the data is tree-like. So the solution so far is to have again a child-parent table, but consider that the root, that it's different, will have an empty value in the parent, right? Now I've discussed this with other people, and they say, well, yeah, that's reasonable, right? So in this case, I'm asking for all the places in Rensselaer County that and their area, right? So it's pretty simple. Well, the query is not that simple, but it's most of the complexities are related to that not all the data in DBP is really clean. So you have to do some things here, and also because the union, for example, here I'm forcing to get the root. This part of the union is just to get the root, and this is for everything else, right? So what this produces, if by adding the circle packing filter, is a circle packing representation of the data, right? Something else you can do. This in this case is finding people influenced by Pablo Neruda, a famous poet. So in this case, the problem with the query, and probably with the SPARQL 1.1, it would be a simpler query, is to get, this is for Pablo Neruda, this part is to the childs of Pablo Neruda, and these are for the grandchildren of Pablo Neruda. So, so again, the final result of this is again a table where you have a root, you have these children, and you have these grandchildren, right? And you can...
You mean indirectly?
In terms of influence, of course, not... Yeah. So adding the... putting this into a Dent program, you will get something like this, right? So now, I would like you to explore this, or try to make something that it's meaningful for you. So now, as a test or something else, I would like you to go to this IP address, 192.168.1.170, and go to the editor. Oh, go to the admin menu.
What network is that on?
I'm sorry?
What network is that on?
Oh, tetherless.
Oh, well.
So you will go to the admin menu.
You can't get to it from the other one. You have to use tetherless.
I think I don't know in terms. I mean, I was trying to create something publicly available, but.
So what? So 192.168.1.170?
Yeah, I'll write it
Yeah,
down.
in the tetherless network.
Here, I'll write it down up here. 192. How about using a pen that we can read?
Yeah.
192.168.1.170.
Yeah, a lot of them can't
So-
see it.
Most of us can't get there.
What?
There it is.
Most of us can't get there.
Yeah.
Just do it live.
Okay. Can you?
Do it live.
Decide?
Just do it for us.
Well, okay. I will do it for you. So, okay. Since this is an administrative section of Visualbox, it requests your password, which is admin by default, not very creative. And you can do several things here, but I'll go directly to the editor. So here I have several examples. I think all of them are described in the presentation. See this by area. This is the code. Basically, all this is just HTML, and the only part here is the Google Maps filter. And the model is here, right? So you can test it, and if the network works fine.
Alvaro, is there an easy way to know what filters you've generated?
Not now, but I wanted to add at least like a cheat sheet.
Right. Yeah.
That, but for now, I think most of them are available in the loudspeaker documentation. All of the interesting ones are available here by example. So you can go here and copy and paste this. And I think I'm having an issue with the result. Of course. So let me see if I can. If I can get the DNS here.
Linux steals all of its icons and metaphors from Mac, doesn't it? And even to the point of the configuration icon.
Let's see if this might work. I have some DNS issues, so I can resolve
Within your machine, or?
within the virtual machine. Oh yeah, it's working. Okay,
There you go.
so it's the same examples as I showed you. So when I want to create a new one, I go to here, I click on services, I add my new component, my new vis. Okay. I click on my new vis, and I will have by default two main files. One is the template, as I said, and one is the query, right? In this case, by default you get a very lame visualization, which is basically it returns 10 triple, and it's displayed in a Google Vis table, right? But it's something that you can have. Hopefully it will work. There's something really bad with this network. Yeah. So that's all you have. Now, for example, can we have something like number of, I don't know how it's the population described in Wikipedia? Wait, there's something really slow.
Who's downloading movies?
Yeah, stop the torrents. So, for example, this is the kind of little annoyances you will have. For example, if you want to get a list of total areas in the US or in a lot of countries, this will give you 2 results for the United States, but you want only one. Actually, you don't care which one it is because the difference is very little. But you want only one, so that's why you have to start grouping or using sample and max, etc. But for now, we'll say country, this an area, right? So now I can go here, and I can decide. By the way, I will run this query against the local endpoint that in this case is Wikipedia, and if everything goes well, I should be able to get a return with all these values, right? So for now, I will assume that these are the correct values. I don't want to start fighting with Wikipedia and testing different queries. But what can I do here is simply to say, you know what, this is bar chart, and the variables here will be country and area. If I save here, and I run this. And if I haven't made any mistake, and the DNS works well. Yeah, there is one.
The sad thing is, everybody is so used to the network being crappy, that we're not thinking this is unusual.
Well, so I will, if the network again allows me, if it allows me to do this, I guess. So there it is. No, it's not. Okay. So I will show you again the visualizations available from the site. Okay, this for some reason it's not working. But basically these are the visualization plus the examples, plus the components. So you can see the query that has been executed and the template used, right? So another thing we should be able to do is to start using different data from different endpoints. And I won't show you an example because the nature of this of the network probably won't allow me. But basically, what I do, I have defined in endpoints. I have defined several endpoints available to be queried, right? So, for example, let's say I want to go to the World Bank. I go to the component editor, and I run bank/main. And this will be another query that will be executed. So the first one will be executed in the local endpoint that happens to be dbpedia, and the second will be executed in the World Bank SPARQL endpoint, right? So now you can use results from the local query to feed the SPARQL query in the World Bank, right? So you can start creating this workflow of queries where one query feeds the queries to other endpoints, or even to the same endpoint. You can create local/query, and that will be executed after the first queries, right? And now you can start creating mashups of different from different sources. I'm sorry, I won't be able to show you a more detailed version of that. But what I can show you as well, I will delete this because I don't want. I hope I can show you this. Oh, there it is. Fine.
Oh, so that's the query that you made before?
Right. So this is the big query that was like 3,000 something, I think, and like 32. But one thing is not work that should work, hopefully, will be that also unless you're using aggregated functions, Visualbox will convert the data obtained from all the multiple endpoints into RDF. So if you request RDF to a visualization, it will give you RDF as well. And if you request JSON, so eventually you could get the semantics of the visualization, not the semantics, but the data use it to feed that visualization, right? You know, it's definitely not working. So any questions regarding Visualbox? I'm really sorry. I will put a new, yeah, there you go.
So it's working, it's just slow.
Yeah, no, but it's painfully slow. So I will post a demo with you guys can play with on a more stable site.
Can you show how you code the filters? I'm really curious about it.
Oh, the filters?
Yeah.
Yeah, I don't have it here. But basically, each filter is a class that that generates some JavaScript, right, based on the input of that you pass. So here, for example, you pass these parameters, right? That comes from the query. So the results you see is variable S, variable C, and variable area. Now you will say I will pass those arguments here, and what this class does, this filter does, is generate the JavaScript to using these variables to feed the visualization. Now, I'm trying to be careful in terms of generating random IDs, etc. So you can you don't overlap. If you put 5 visualizations in one page, they shouldn't overlap. They shouldn't collide. So yeah, as you can see here, you have 3 variables and you have a bunch of results. So let me see, this is running. So basically you can create different visualizations based on linked data. And I'm really sorry, I really wanted you to play a little bit with this and have a so this is not finished.
So they're all.
But this is basically
code?
this is Java. This
Oh,
is
that's-
D3,
Okay.
but it's being generated by some PHP code here, right? And these are the defaults that later you can override in the parameter of the filter. So, for example, if I don't like the color of the nodes, for example, I can change that, or I want the window, the SVG element to be bigger or shorter, I can change that. So it's not one fixed visualization, but you can do some tweaking as well.
So go to, so that's a D3, so.
Right. This is not finished. Let me show you this one for now. So this is basically it tells to generate to generate an SVG, append a group, and then using the JSON element, the JSON variable that takes all the results. It will generate the circles or whatever. These are the lines that for the visualization. So let me show you the code that it's generated. This may be. How do you see the code here? I don't want to reload it. Anybody knows how to see the source code in? Okay.
Right click.
Right click?
You have to have the developer tools on in the advanced settings of Safari.
Okay.
It's a Mac, you're not going to get to see the inside.
Yeah.
no user serviceable parts in the browser.
Yeah. So this is generated, hopefully.
But, okay, so that filter looked remarkably like D3.
No, it is D3.
Okay, but now, so what if you go?
I mean, I'm not claiming I invented the
No, I know,
visualization.
but if you were to go to one of the Google Viz ones,
I'm sorry?
if we were to go to one of the Google Viz ones, we're
Mhm.
going to see.
Google Viz JavaScript generated.
Right, okay.
Right. Yeah, no. So basically, I'm taking advantage of all the visualizations I have used over the past years, and I'm putting it in a way that creating a new visualization is not a pain. Oh, I don't remember the format of this, or I don't remember what library if version 1 work or it was version 2 or I don't know, that kind of stuff. This simplifies the way you create a visualization in terms of you only have to worry about the data you get. You get the data. Once you get the data, you get the query right. You will there won't be any trouble creating the visualization you like, right? As long as I have created a filter for that. By the way, I'm really interested in having very interesting and attractive visualizations for this. So if you have something in mind that I haven't showed, I will be more than happy to create a new filter for that. So this is the code. This is for a visualization, a Google visualization. So the code is pretty straightforward. You have the options. These are the default options that can be override. You generate the draw chart, the draw chart function, and this is the code, right? This is the code generated using the results from the Wikipedia, right? And that's it. Actually, it should be a bar chart ID, some random ID. This is about. But in this case, it's with a random ID. So that's it. I mean, you can do this. Everybody can do this. But in general, everybody gets something really not really well. And debugging JavaScript is kind of painful. So that kind of stuff is avoided. But especially if you want to do several visualizations in one page.
You know, so one, you're asking for suggestions.
Mm-hmm. Yeah,
Okay.
absolutely.
One specific. So a way to really demonstrate this in a cool way would be able to swap a couple different filters that basically do the same sort of visualization, but on different
Different libraries, you mean?
Right. Yeah. Exactly. So one of the things we had over the past couple of weeks, or about a week ago, with Orpedia and creating a demo, was we wanted to be able to swap different Google Maps or different visualizations. We often use an intensity map. We had one particular intensity map which was sort of map the world. Mm-hmm. We wanted to swap with the simpler intensity map of the U.S.
Okay.
And then we thought, well, what if we had there's a really cool D3 intensity map, mm-hmm. and there was another one we found, and it would have been with the same JSON feeding it, okay? And it would have been really cool to be able, I mean, in here, you can see exactly how you do that. You know, you've got your parameterization, and you just right. Change that filter, go pop, 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 pop. Mm-hmm. So that would be, that's a specific example that you could show is here are several different filters that basically do the same thing. And voila.
Yeah, that could work, definitely. Well, as I showed you here, it's not that exactly that, but what I mean is, from here to here to here, you only change the filter.
Right. That's exactly the same.
But you say like using that the result should be similar.
Right.
Yeah. One thing I forgot to mention before I forget. I'm putting the data here. I'm not doing an AJAX request, and that was a conscious decision And the decision was, hopefully the server will have better bandwidth than your client. But more importantly, what happens if the VPD is down? Something that happened yesterday, for example, right? I still want a visualization that I can embed somewhere, or I can show to someone just by copying and pasting the code. And if I need an Ajax request, for example, I'm still dependent on the SPARQL endpoint from where it was taken. And I think that in some cases you just want the visualization and forget about the SPARQL endpoint. So that's why you put the data hard coded into the visualization, and not you don't do an Ajax request. You see what I mean? I can put this, and it doesn't matter if the VBD is down. I can put it somewhere else. I can embed it into a web
So
page.
once it's generated,
Mhm.
then it's,
Right, of course. But what I mean is that I don't have to be dependent of every single time I want a visualization. I need to generate it. So I generate it every time I'm sorry. I generate it every time I request this, but I can take this code, copy and paste it, and put it somewhere else, and I don't need to depend anymore of the SPARQL endpoint, right? So what is the main goal of this is to allow non-semantic web geeks to simplify the process of using this data. Now, I am aware that you still need to know, despite any visualization filter you might think of, you still need to deal with the SPARQL part, which is not easy. It's definitely not easy. So I'm not sure yet how to deal with that. I've been doing some work related to that with Visual SPARQL, but it never went to any good way. But the idea was to allow you. Oh, come on. Let me change. The idea was to being able to create certain SPARQL queries graphically, right? So you don't need to write SPARQL. No, this is not working.
well, but what you have done though, is you've closed the gap between hacking with the SPARQL query, which is often how you then explore the data,
Right.
and creating a visualization.
Right. Yeah. No. The gap is definitely shorter this way, but
Yeah.
I don't want a gap.
Yeah.
So, or I want a very very tiny gap. So,
But I guess what I'm trying to say is there are different problems. You know, there's the problem of you know.
yeah. No, I agree, but
I mean, you can't,
Yeah,
you,
so-
can't, you can't babysit the user on everything. Right?
so this was the idea. The idea was to embed this into Visualbox. So I create a new node, say X. This will be a variable, and I will link this to this based on, say, Fournier. So now I'm creating the query graphically, but I did some preliminary studies and it was too complicated. The people I asked, can you do a query? They said, I have no idea what I'm doing. I'm just double clicking here, clicking there, but nothing else.
SPARQL whack-a-mole.
Yeah, exactly. So I'm very very open to suggestions on how to deal with that gap, to make easier for people to create queries or more broadly said, to allow people to request the data they want, because at least with my opinion with Visualbox, the part of creating the visualization is simplified in great manner. So we need now to focus on how to deal with the SPARQL part.
So one of the things that's I'm kind of curious about
Mhm.
is the there's a certain amount of work that is behind the curtain here in terms of creating those filters. You know, that for example, I mean, the D3 based visualizations. You're doing a service to mankind by making those parameterized, but you're still, to create those filters, you're having to break open a D3 code. No, you're not using the standard functions. You're having.
No, I'm using D3.
You're using D3, but aren't you having to wrap them, or? You're not,
Oh yeah, no, it's wrapped into a function for each visualization.
Right.
Just to avoid overlapping with other variables. For
Right.
example, if you have two visualizations using the same filter, I don't want that the variables collide. So I have wrapped them in functions with random IDs, UUIDs.
So you've got sort of an obfuscation layer that allows that.
Yeah, but it's not obfuscation. It's just avoiding potential collisions of variables. So,
And
but
that's the same
just-
as what you do with the others, like the Google Viz
Right.
stuff.
Right. Well, the Google Viz I think was one of the first attempts, so probably doesn't have all that nicely. But for example, let me show you the last one I did was, I think it was this one. And
So you're wrapping that in PHP, right? Or
no, the PHP generates the JavaScript, right?
Oh, right.
And the JavaScript, most of it is standard, right?
Okay.
So in this case, the function, and I won't execute this because of the network, but basically it's init d3 first graph blah underscore blah blah blah, right? That it's this variable, and the same for the JSON object. It's JSON d3 blah blah blah, right? So you won't get any conflict on, well, unless you're really unlucky, but assuming some random variables almost guarantees that you won't have any trouble with that. And the rest is just D3, right? So appending things, adding the force layout, etc., etc. So it's pretty straightforward.
So how ready for use do you think this is? And what operational aspect of that is, should I tell my class?
Well, it should be ready for November 12th because I will present this in the Mozilla Festival, and they're really excited about it. Yeah, I have talked to some people in your class, and they asked me if I can show this to them. I think that if you want a visualization, this is you can use this. That's fine. If you want something more complex, like if I click here, something happens here, I think that you still can use it to start as a scaffold somehow, and from there create your own thing. But this won't do it. So if you want so for example, let me show you something that I created.
Yeah, I guess that was going to be one of my questions. Is are you exposing interactive aspects of the visualizations? No.
Not now because I haven't figured out how. I might be at least leave some hooks. So say like if you write JavaScript, okay, this is a hook that you can specify. Give me the ID of this visualization so I can also add more JavaScript and do something with this when something happens, right? But it's not my focus with this work to give you a full programming language framework, etc., because for that you need to learn JavaScript or Python or whatever, and then this problem is solved. I mean, the problem, what I've seen is that a lot of government people, a lot of NGOs, a lot of journalists want to use data, want to create visualization, and they can't because they don't know how to do that. Oh, seriously? So for me, that's a core problem. Having a semantic web hacker that this might simplify his work, definitely. But if this doesn't exist, he still can work his way around by just coding JavaScript. But yes, definitely, if I'm able to install a visualization, an instance that works, like I was having 20 minutes ago or 1 hour ago, I will be more than happy to give you the pointer and let your students to.
Okay, so it would be nice if you could give me a blurb
Okay.
describing it, why you would use it, and then
Okay.
answer.
Yeah, absolutely. Yeah, I have some documentation, but I can't show it now. But yeah, I can leave an instance running so they can create their own visualization. And I still need to add the cheat sheet so people can see what's the what are the filters available and how to use it. But that shouldn't be hard. So any question? I'm really more looking for your comments, suggestions, criticism. Everything is fine, but I really want you people to let me know what do you think in terms of usability, in terms of this, if this makes sense to you guys or it doesn't. What would you add? What would you remove from it, etc. But this is not one hour.
Do you want the power thing? My Ethernet cord is connected to this as well.
Okay, yeah, sure. At least to show you the site and the visualization site and all that. Okay, so this is a site using the data from the Global Hunger Index. I did it with a full version of Loudspeaker, not Visualbox, but the results are the same, right? So in this case,
Maybe you could talk a little bit about the difference between that.
no, the difference are very subtle. It's basically you see less things in Visualbox. For example, Visualbox doesn't allow you to create types or URIs, so you cannot publish RDF on your own, right? One of the initial goals of Loudspeaker was to being able to publish data. So you have your data in your triple store and you publish it through Loudspeaker using content negotiation, etc. But another thing of Loudspeaker is to create these services. Visualbox provides you only the services, not the types, right? Because it doesn't make much sense to have it, and it confuses or my impression is that it will confuse the people. What is an RDFS column resource? I just want to create visualizations.
So you're gonna charge for a loudspeaker or not charge for?
Something like that. So. So the difference is that here I have all these types, right? And sometimes and eventually I might have a URI, but in Visualbox you only have this part, right? Mm-hmm. That's one difference. The other difference is that Loudspeaker allows you to, if configured properly, it allows you to add RDF or remove RDF in terms of name graph in your triple store, right? But Visualbox doesn't, because it doesn't have a triple store to be edited, right?
In memory or?
No. Talking to a triple store. Say any triple store that implements RDF through HTTP, it's allowed to you can configure it and you will be able to add or remove data. Right? The rest is the same. You can configure the namespaces. Loudspeaker and Visualbox works a lot with queries, so you need some prefixes. You can edit them. You can create, add, or remove endpoints. So for example, if I say, you know what?
You know, you have to check on this every week to see the new features.
So let's assume I have a data stored localhost, so I can put it here, and that's pretty much it. And Visualbox allows you to edit namespaces, endpoints. It doesn't allow you to load or remove data because it doesn't make much sense. Again, for people that just want to create visualizations. And the editor is similar. Well, yeah, this is pretty similar. So you have the same queries. You have you can test it. Of course, this won't work because this thing is not working. I don't know why. But okay, nothing seems to work today, so I will leave it here. If you have any questions on how to use it, drop me a line or just talk to me.